This video is for graphing systems of equations to solve, and I'm in a meeting this afternoon, and so this is your notes. So you need to make sure you have the graphing system and notes paper, and we're going to go through that and do some other problems and show you a few things along the way. Okay, so a couple things we've been reviewing, but you need to make sure that you remember how to graph lines. We want the lines to be in slope-intercept form, and that's going to be important here. And so slope-intercept form, we write our slope as a fraction, and then the y-intercept is the second number. So if it's in slope-intercept form, you're good to go. If it's not, you need to put it in slope-intercept form. So that one, we start at -1. The slope is -3/1. So you can either go down 3 and to the left 1, or you can go up 3, or to the right 1 and up 3 and to the left 1. And then remember, just double check, the slope here is negative because slope dude is cruising down nice negative. Over here is not in a nice form for graphing, so we need to first solve for y, get y alone, and so I have moved the x term. I'm dividing everything by 2. Make sure you write the x term first when you move it so that you can actually graph. So -3/2 x plus 2. And notice I wrote the 2 underneath each term. So the y-intercept is 2. And the slope is -3/2. So I'm going to go down 3 to the right 2. Or up 3 to the left 2. Should line up either way. Okay? So that's the single skill for graphing lines that you need to be able to do. So if you can't do this one, go back to your Khan Academy and do that practice, because you're going to be in trouble. Okay, so the next thing is this problem, just to kind of get you thinking about what we're doing. Biology study the weight of 2 alligators over a period of 12 months. The initial weight and growth of an alligator shown below. So we have their initial weight, it's like their starting amount, and then we have a change of 1.5 per month. And the question is, after how many months? So we're trying to find how many months they weighed the same. So in other words, when is alligator 1 equal in weight to alligator 2? So one way you could think about it is they start at 4 and 6. After a month, this one is 5.5 because it gained 1.5 pounds. This one is 7. And then this keeps going up. So this one's 7. This one's 8. And you could keep adding like this. And you can see we're catching up. So we know it's at least 4 months. But if this was a really long, they're really far apart, it wouldn't be a very good way to solve it. So the best way to solve it would be to set 2 equations up. And the first one for alligator 1 is 4 plus 1.5x, or m if you want to call m for months. And you say that's my first equation. My second equation would be 6 plus 1x, or x. And we would write it in slope-intercept form, switch the order, but you can find 2 equations. We're not going to spend a lot of time on that word problem there. I'll show you a picture of, so I'm going to put that in equations, but this is what happens when something is equal. We're looking for where they intersect. And so this is an equation, how it would look, and you could graph both of them as lines, and you can see where they intersect. The point where they intersect, that is the solution, and it's a coordinate. It's 4, 10. So after 4 months, they were both 10 pounds, and that's where and then the other one passes it up. So a good graph is sometimes a good way to solve you see this in economics. There's a break-even point. It's where anything above that, you make money. Anything below that, you lose money. I'm going to keep going. So what we're going to do today is we're going to intro the systems, graph the systems, notes, and then there's some practice. It's going kind of slow here, so I'm zipping you through it. We will learn multiple ways to solve. Today is just graphing. Okay, so here's some systems, and this question says, this is something we will be discussing in class. What do you notice here? Well, the thing that you notice is we're not solving for x. We have an x and a y. We have an x and a y. We have an x and a y. So if there's two equations and two variables, we call that a system. That's what you can notice. So this goes to the first definition on your notes page. So pause the video, fill that in. What is a system of equations? Two equations with two variables. Get out your notes page, fill it in. What's a solution to a system of equations? We looked at that alligator thing. It's an ordered pair. So you also might add, it's where they intersect, where the two lines intersect. And just like a solution of an equation makes it true, the solution to a system makes both equations true. So for instance, this one they're asking you, is 4-2 a solution to the system? This is example 1 on your paper. And the reason we start with checking a solution is because you need to know how to do that and understand where it comes from before you start solving. So all you do to check a solution is you plug in 4 for x and 2 for y on this one. So 4 minus 2, is that equal to 2? Yes, it is. And then you plug in 4 and 2 again. 4 plus 4 times 2 equals 12. Is 4 plus 8 equal to 12? Yes, it is. So if it works in both equations, then it's a solution to the system. Okay, so write that in. That's your checking a solution notes. Pause if you need to. Is 2-1 a solution to the system? We're going to plug in 1 for y and 2 for x. Put parentheses if you're multiplying. Right here we're going to plug in 2 for x, 1 for y. Be careful you don't kind of mix the two things together. So is 4 minus 3 equal to 1? Yes. Is 1 equal to 3? No. So answer would be no. If it's not true for both, then it's not a solution to the system. Okay, so we're going to begin solving by graphing. So here's your step. Step 1. This is the next thing in your notes. Write it down. Graph both lines. Use a straight edge. Be exact. Find the intersection point. And then the solution is the point where they intersect. So find the coordinates of that. Remember, you're not finding slope of a point. Don't get those confused. So these are your 3 steps. Put them on your 3 steps. It's going to be just a good review of graphing lines as well. Okay, so for the first one here, I'll do the first one, all the steps, and then you can write it down, but then you can work ahead after that. So I'm going to write the slopes both as fractions. So I have a slope or a y-intercept of -4, and the slope is +2. So what I like to do, instead, I don't have a straight edge here on my computer, so I just like to make those dots because the dots are going to be where they intersect anyway. Okay, and then I'll switch colors. And so I start at 1, and the slope is down 3 to the right 1. And right away, I can see where we shared this point, and that's going to be my solution. So at this point, 1, -2, that's my solution. And then you want to always make sure you go back in and put in your lines. But if you just make the points, you can find where they intersect, and your lines don't have to be quite as perfect. Okay, so go ahead and pause this, and you go ahead and graph number 2. So I went ahead and plotted them on here. It's in slope-intercept form. Should be pretty straightforward. So you can see on my green and my red where they're shared, right there. That's the solution, 1, 1. And you could quickly check it in the equation. Is 1 equal to -3 times 1 plus 4? Whoop, it's gone. All right, we go to the next page. You can pause it right now and do number 3. Don't be a cheater. You know where they go. Hope you weren't a cheater. Right here's my intersection at 3, 2. Now we get to the good stuff. This is where all that stuff you worked on first semester about graphing is going to come pay off, because you need to be able to solve both of these 2 equations for y before you start graphing things. So you're going to need to solve that for y. I'm going to clear a little bit off here. And so 5x plus y equals 4. I'm going to get y by itself. So move the x, and then this one I don't have to divide by anything. So there's my first equation. Second one, be careful. When you move, you don't lose your negative. There's a negative y. So I'm dividing everything by -1. So y equals 2x minus 3. So I have 5x minus 4 and 2x minus 3. Or -5x plus 4. So there's my 4. Down 1, 2, 3, 4, 5 over 1. 1, 2, 3, 4, 5 over 1. It's down here. And then 2x minus 3. I got my solution. So I'm going to go ahead and just sketch my line in. Once I get my solution, I don't have a straight edge. So 1, -1. Okay, number 5, I'm going to keep going through here. You can write these down. If it's too fast, stop it and fill it in. If you come back to class without anything on your notes page, I'm going to make you watch it while I'm standing there. So y equals -4. That's a horizontal line. Remember, think about us putting our arms out, saying y equals x equals. So y equals -4. And then this is a nice line, 2x plus 2. So I start at 2, up 2 over 1, or down 2. There we go. Got my solution. Can fix the rest of it. -3, -4. This one you need to solve both of the equations. I'm going to pause it and let you solve it, and then I'm going to put the graph on there. So this is y equals 7x minus 3, and this one should be y equals x plus 3. So I'm graphing 7x minus 3, 1, 2, 3, 4, 5, 6, 7, 1, and then x plus 3, starting right there, up 1 over 1, there's my line, solution, 1, 4. Almost through this here. Remember yourself, okay, when you make this, and making your arms go up and down, you're saying x equals. So x equals -3. That thing's ready to graph. Just graph it. And then I need to solve this one for y. So 2x minus 3y equals -3. Got to be able to put stuff in slope-intercept form. It's like solving an equation first semester. You don't believe us until you believe us. Key step is dividing by the right amount and not losing your negatives. So this is y equals 2/3 x plus 1. So up to the right 3, or down to the left 3, and there we go. There's our solution. -3, -1. Okay, I'm pausing it. This is the last one, but I want you to solve both of these for y. Okay, so you solved each of them for y. And something looks fishy. Something looked fishy right here, but let's go ahead and graph it. So -2x minus 1, starting at -1. Down 2 over 1, up 2 over 1. So I got my points there. And then, let's go try yeller. -2x plus 4. There's my 4, down 2 over 1, down 2 over 1, down 2. Mr. Kirkton, I need my graph paper because it's not going to intersect. I don't have enough room. And you're like, well, this is never going to intersect, little one. These are parallel. And then you remember, back to what you learned first semester. When you have the same slope, lines are parallel. So if these have the same slope, they're parallel. They're never going to intersect. So there is no solution. No solution when you have parallel lines. So there's some options for our answers. So no solution, we just figured that out. Whoa. No solution is when our lines are parallel. One solution is what we'll do most of the time. They're going to intersect at one point. Or infinite solutions. That means when you go to solve for y, you get the same equation for both lines. So you're basically graphing the same line twice. So they share every point. So if sharing a point is a solution where they intersect here, you got it. Okay. So we're not going to do the partner check in my class because I'm not here. So what you're going to do is go pick up the individual practice paper, and it says individual practice graphing systems of equations. And you're going to do these problems, and you're going to then, when you're finished, come get an answer key from the teacher and check it. And then you can work on Khan Academy. You can finish your weekly review, the last two questions, in case you don't know how to do them. But Khan Academy, most of you have plenty to do on that. And then we'll grade right away we'll grade the weekly review on Monday. Okay, so get the note, go back and fill in notes if you don't have it yet. You're going to pick up the individual practice, check that, and then you're going to do the weekly review. You can get to work. Don't be an idiot. Be polite. See ya.